Hi guys, it's Ethan. I haven't made a video in a while because I haven't been at school, so I haven't had access to a Blackboard, but I'm back. And today I'm going to be going over possibly one of my favorite applications of math. It's called the secretary problem. And I'm really excited to do this video because I actually use this a lot in my daily life. It applies to a bunch of different things like parking or dating or like apartment hunting. It has a bunch of like really cool applications. So you should watch this video if you're interested in math and how it applies to real life. Okay, so basically, how this was formulated is um, some people wanted to figure out there was a problem, right? So some guy he was hiring people. He was looking for a new secretary, right? So he has a bunch of like secretaries he's looking to hire, and he wants to hire the best one, okay? But the thing is, he can only look at them one by one, okay? But he does also know like how good they are based on like a rating. So you can only look at them one by one, but compared to each other, they have a rating. So let's say this one is like the secretary is like a 7, like she's a good secretary. This one's like a 2, she's not that good of a secretary, and so on and so on. And once you look at a secretary, you can't, if you reject her, then you can't pick her to be your secretary, okay? And so these people wanted to optimize this and find the solution. And so what did they come out with? Well, the answer is actually, it has a really cool formulation. The answer is actually 1/e. So to solve this problem, you look at the first 1/e candidates, and you don't do anything. You just consider them. So you look at their rating, you say, oh, 7, 2, maybe this is like a 4. Okay, so you look at the first 37%, which is 1/e. 1/e is approximately 37%. So you look at the first 37% without making a decision, and then immediately after that, you take the next best candidate. So if this was like a 7, and then after 37%, 7 is the best one, and then like later on you come across an 8 out of 10, you would take this to be your secretary. Even if there's still like 60 more applicants, let's say there's 100 secretaries, and number 60 is an 8. Well, according to the solution of the secretary problem, you would still take this 8. And very interestingly, this has a 37% success rate as well. So after looking at 37% of the applicants, you take the next best applicant, and the chance that you selected the best applicant is also 37%. There's a really cool proof involving calculus, but it definitely deserves its own video because it's very long. But yeah, so this is the secretary problem. There's more formulations of it. One of them is like a pharaoh who gives you like a basket with like a weight of like silver or gold, and there's like 100 baskets, and you can look at each one, but you can decide whether to take it or not. It's basically the same thing, except with like monetary value instead of like a person's working ability. Okay, but how does this apply to real life? Well, it gets into like the trade-off between like exploring and exploiting. So let's say you go to like a new city, right? And you're there for 2 weeks, okay? So this will be our city, right? And there's a bunch of different restaurants you can go to. This is gonna be about like eating in a new city. So there's a bunch of different restaurants. Okay, let's say you go to one restaurant your first night, and it's pretty good. It's like an 8 out of 10. Well, the secretary problem gets involved in actually like deciding what restaurant to go to. Because, okay, you went to this restaurant first. Do you risk it and try a different restaurant the next night? Or do you exploit the knowledge you already have and go to a restaurant that you know is already pretty good? And so there's a trade-off here between exploring and exploiting the knowledge you already have, because this restaurant, it could be really good. It could be like a 10 out of 10, and you would be missing out, which leads to like regret. And like mathematically, the way to like ultimately be happy is to minimize regret. So we'd be losing out by just sticking with this place. But this could also be bad, and this could be like a 3 out of 10. But then, hey, we know that this place is pretty bad, and we're not going to go here. So, so how does this apply to the secretary problem? Well, we don't have candidates, so it's a little bit harder, but you can think of it in terms of like a time frame, okay? So if you're in a new city for 2 weeks and your goal is to maximize like your eating experience and like good restaurants that you go to, well, you would want to spend 37% of that time exploring new restaurants, okay? So if you're there for 2 weeks, like 40%, you spend like 5 days eating at different restaurants. And then after that 37%, you can exploit the knowledge that you gained in exploring and you can just eat at your favorite restaurant. And that is a way to minimize regret. It also applies to parking. I was using this today. I was parking at the gym, and to find the best parking spot, I always talk about it with my dad. It's like a little inside joke, kind of. If you have a bunch of like different parking spots, if you want the best chance of getting the absolute best parking spot, you drive through 37% of the parking lot, and then as soon as you see the next best spot, you evaluate like what the best spot is, like before that 37%, and then if there's a better spot in that from that 37%, you take it immediately. It doesn't matter if there's still like 20% left of the parking lot or 50% left. If you find a spot that's better than all the other spots after exploring 37% of your of the parking lot over here, you should take it, and that gives you the best chance at optimizing your success. So this is a really fun application that I learned a while back that I've been applying ever since, and I hope you got something out of this video. So thank you.